Technology Domain of the 108 Curriculum Guidelines, Extended Course, Applied Technology Project. Today we will explain to all teachers that amongst the extended courses of the technological domain of the 108 Curriculum Guidelines, there is one course on Applied Technology Project. In the presentation today, we are going to explain to every teacher the learning content and the learning objectives of the Applied Technology Project within the extended course of the 108 Curriculum Guidelines. In the second part, we are going to explain to the teachers what preparations they can do when offering this course or preparing for the course. The third part of the learning objectives is that whether students select this course or participating in the learning of this course, they should have already done some reviews or conducted some preparations. The fourth part is how this course can be planned in the academic portfolio of the 108 Curriculum Guidelines, or how it can guide the students to write a suitable academic portfolio. The fifth part is the review and evaluation methods of this course. Since it is a project, therefore, in today's course, we will provide some different approaches for the teacher's reference. First, let's learn about the extended course, Applied Technology Project. Technological Domain Course and Credits. Under the structure of the 108 Curriculum Guidelines, a senior high school can gradually break away from the fixed class course schedule and learning method to head towards the student-oriented learning course design, where the students can consult with the teachers and counselors for guidance and suggestions via the course to select the relevant course module conforming to the faculty requirement of future university, or relevant professional learning course modules combined with hobbies. In order to cultivate proactive learning attitude, in the technology domain, there are two required courses, which are respectively Living Technology and Information Technology. These two courses are 2 credits each. In technology domain, there are 2 classes each week, 1 class per week per semester for information technology. It is the same for living technology. It mainly focuses on cultivating students with the ability to solve problems using computational thinking and the ability to communicate, express, collaborate, and create. Living Technology is a 2-credit course, with optional courses including Engineering Design Project, Domain Course Applied Technology Project, and Domain Course Robot Project. Both are 2-credit courses. The course planning for Living Technology can mainly connect to the Information Technology group, the Engineering group, and the Architecture and Design group at the university end. Among these, the Information Group emphasizes various levels of theoretical and practical skills regarding information processing, including computer program design and system computer hardware and software structure, network setup, information security, organizational planning, and management of information systems. The Engineering Group includes all engineering-related faculties, combining fundamental science knowledge with engineering techniques, then dividing them into various specialized domains according to production practicality to cultivate senior technological talents. Information Technology is also a 2-credit course, with optional courses including Advanced Program Design, and just as the same as Living Technology, there is also a Domain Course Applied Technology Project and Domain Course Robot Project. These are also 2-credit optional courses. The planning of extended optional courses for information technology follows the concept of the technology domain, as well as students' career development and social development needs as the foundation, cultivating students' ability to solve problems via integrating and applying computational thinking with information technology. Planning advanced program design, robot program design, and applied information technology project These 3 extended courses are provided to students for the opportunities of adaptive development and self-actualization. The course planning for information technology can mainly connect to the information technology group and the engineering group at the university end. Among these, the information group emphasizes various levels of theoretical and practical skills regarding information processing, including computer program design and system computer hardware and software structure, network setup, information security, organizational planning, and management of information systems. Thus, through the Advanced Program Design and Applied Information Technology project, one can learn about the theoretical and practical foundations of information science needed by this group, and further explore the interest in information domain development. Applied Technology Project course and credits emphasizes the technological integration ability of computational thinking and design thinking. From an international perspective, many advanced countries set up technology domain, emphasizing the knowledge integration of subjects, including science, technology, engineering, mathematics, and arts. Through the setup of the technology domains, the contents of information, technology, and engineering are incorporated into the course planning for the technology domain, where the information technology course is provided for students to learn about the computer science-related knowledge to cultivate students' computational thinking, while the living technology course provides students the opportunities to learn about the common knowledge, tools, and skills about technology to cultivate students' design and production abilities. Big data can be integrated and used for analysis. For instance, the healthcare industry applies big data analysis technique to accelerate the development of new medicines and healthcare equipment, introducing changes to health management and diagnosis and treatment. If applied to the manufacturing industry, it is not only capable of effectively controlling operating costs, but can also observe the market trends to get to know the client's needs in advance. If big data can be collected and analyzed, it can effectively assist enterprises in creating opportunity for growth. Data mining. Data mining is a computer science that explores meaningful information or mode from the data collection via the automatic or semi-automatic approach. The mode mentioned here is the phenomenon that can repeatedly appear. Therefore, one can treat data mining as a subject that explores knowledge among data. Data mining is also a cross-field subject, including machine learning, AI, pattern recognition, statistics, and database system. Image processing and recognition. The 2 nouns of image processing and image recognition are similar, but their meanings are completely different. The former one conducts some reinforcing or simple calculations on the images to highlight certain characteristics that we want to know. But its output data is still only one image. For example, an outlook of something. In contrast, image recognition must have distinct text or numeric output. It must be so distinct that it can become the data in the database, capable of providing information that can be searched, analyzed, and compared. Technology domain, courses and credits. Graphics. Graphics is a science that expresses the form, size, and manufacturing of objects with pictures, symbols, and texts. It is also a tool for the engineering unit to convey ideas and exchange knowledge. It is also known as a pictorial language, the language that engineering personnel must be proficient in. Artificial intelligence. Artificial intelligence is not restricted to the application in information science. There are many other different subject domains related to artificial intelligence. For instance, combining mechanical, control, and industrial engineering with robots. The technology of artificial intelligence is also applied to the completion of human gene mapping, as well as the data decoding and categorization required by biotechnology. It is a technology with extremely high potential for development. Network. The Internet is an indispensable tool for future learning, working, and living. Among these, the World Wide Web possesses features including multimedia, hyperlinks, integrative service, etc. It will become a vital communication medium. The principles of engineering design emphasize project activities via engineering design, allowing students to learn about interdisciplinary knowledge integration and thereby develop their high-level abilities towards design, innovation, and critical thinking for the technology and engineering domains. Electromechanical principles. The scope of electrical and mechanical integration includes mechanical engineering, electronics and electrical engineering, control engineering, and computers. Originally, the combination of control engineering with computers should enhance automation control from analog control to digital control, then integrate with mechanical engineering to become the CAD system, etc. Its related technologies include materials technology, biotechnology, manufacturing technique, chemical engineering system, healthcare technique, and communication technique, etc. The application scope for mechanical and electrical integration is vast, ranging from the industrial field, transportations, office automation, household electrical appliances, 3C system, medical engineering, and remote nursing system, etc., just to name a few. Technology product design integrates the principles and skills learned previously to the actual applications, and, in the end, computational thinking is fused with design thinking and becomes the conceptual idea for the prototype of the technological product so as to be applied in doing projects. This allows students to voluntarily learn about the information technology application principles and implementations related to the application theme, thereby completing the project via the advanced engineering design and implementation. Course objectives. Cultivate the ability to explore new knowledge regarding the technology domain through selection, analysis, and application of new knowledge to effectively plan career development, explore the meaning of life, and constantly improve oneself in the pursuit of perfection. Cultivate the ability of management, effective communication, and teamwork problem comprehension, and critical analysis, reasoning and systematic thinking, and metacognitive literacy, as well as the ability to take action and reflect in order to effectively handle and solve problems. Cultivate the ability to apply information technology for data access, analysis, and computation. It can be extended to incorporate the ability to know the techniques, understanding of the products, sensitivity towards the data, and the mutual transformation between data and product. The scope, depth, and speed of analytical thinking and the ability of mathematical statistics, as well as the ability to communicate. Cultivating the ability to implement software and hardware is the most popular phrase in the field of technology now. Products with software and hardware, literally. This is usually the part where people focus on the new functions and applications. However, a vital factor, which is hidden behind the combination of software and hardware, but has never been mentioned and paid attention to, is product design. It is also, as mentioned previously, how to fuse computational thinking with design thinking for further application. Cultivate the ability to integrate computational thinking with design thinking. After learning the 4 course objectives mentioned before, understanding and extending the applications for carrying out the project, the development of the topic, the exploration and extension of the content, and the presentation of the results. Learning content. Principles of Information Technology Application will teach about computational principles. The sophisticated AI algorithm training and calculation often involve tens of millions of arguments. The calculation of these arguments requires significant calculation ability. GPU calculation is now the mainstream in the deep learning domain. At present, the mainstream GPU features strong calculation ability and memory bandwidth, where the efficiency and memory bandwidth are far greater than the CPU of the same generation. Meanwhile, the parallel computing ability of GPU is also a significant advantage. In information technology application implementation, one can learn about the implementation method and performance evaluation. After understanding the concept, they can integrate the content learned during the actual operating process and further conduct performance evaluation and test the implementation content. In design and production, one can learn about advanced engineering design and implementation, user needs and market analysis, design and development procedure, functional analysis and innovation, mechanics simulation and analysis, and computer-aided design and manufacture. The learning performance of the technological domain courses includes computational thinking and design thinking. Design thinking. By observing and solving problems in life, it emphasizes the ability to perform, use, and think. It cultivates students' ability of DIY, using technological products, and design and critical thinking. It can be integrated with advanced engineering design and implementation, design and development procedures, and computer-aided design and manufacture. Computational thinking is the learning of related knowledge via computer science that cultivates logical thinking and systematic thinking, etc., thereby enhancing the student's knowledge towards computational thinking and design thinking in the process of making the technology project and solving problems. It cultivates appropriate attitudes and habits of teamwork. It can be integrated with user needs and market analysis, functional analysis, and innovation mechanics, simulation, and analysis. Second, preparations from teachers. Next, in this course of Applied Technology project, we can use some documentation for the students' learning process to increase the students' data so that they will have information for reference when working on the project documents or the academic portfolio at the end of the semester. All teachers. Next, in the course of the Applied Technology project, how can we assist the students to prepare or record some documents? We are going to use Google Classroom this time. Here, we have prepared a classroom dedicated to the Applied Technology project. We call it the Simulating Classroom. In this classroom, we have mainly established 4 major document preparation directions. A. Basic ability training. B. Project theme discussion. C. Project progress record. D. Project presentation. We will introduce to the teachers each of these one by one. Resources. Education Cloud. Let's see what they have for junior high schools. You can go to the Education Cloud website and search for information technology-related links. Refer to other junior high schools' teaching content to understand the learning targets and contents. It is capable of guiding the students in the teaching and helping the students in planning the course. Let's see what they have for senior high schools. Go to the Education Cloud website and search for computational thinking-related content. The learning targets and the curriculum guidelines of technology domain. Focus on computational thinking and design thinking. Understand how to apply tools to improve life and stimulate national industry and economy in this era of big data. Through computational thinking, The computability of problems can be managed, meaning whether or not computational tools can be used to solve them, and then further effectively use computational methods and modes to solve the problems. Preparations for Applied Technology Project. Students' prerequisite capacities. When involved with new learning, the ability that must be equipped in advance or must be learned first, meaning that one must master the lower level abilities before advancing to learning the next upper level ability. Looking from an alternative perspective, prerequisite ability can be treated as a preparation for learning or an internal condition to learning. This concept implies that learning has a cumulative characteristic, meaning that simple learning is the foundation of complicated learning. The abilities learned before can be relocated to subsequent learnings. Information Technology Concepts Learning Status. Be aware of whether or not the students understand the course content at all times, whether or not they can catch up with the progress, whether or not they can apply and perform in the project. These are all things to be noted by teachers. Students' learning differences. Students with learning differences have different learning modes compared to their peers of the same age. They may show learning difficulties when accepting standard teaching and learning styles. They need coaches who understand their asynchronous psychosocial development. Adults, as their learning target, are role models to closely monitor and guide them. A loving and comfortable school environment and sufficient companionship, as well as a comprehensive and professional career development plan are needed. Students' target differences, such as software, mobile phone app, system development, hardware, combined demo board, the fundamental spirits and meanings of differentiated instruction are accepting the different learning methods of each student. Their different prerequisite knowledge, their different learning interests, their different learning needs, due to the differences based on different factors. Different teaching strategies must be adopted for teaching. The objective is to allow students with the best learning effects to clearly know the differences and applications for the software and hardware content when learning. Weekly progress or time allocation. In the first week of the course contents will be introduced to the students, along with the learning targets, allowing them to understand what problems they will encounter and what preparations must be done for the future course. Also, in the course intro during the first week, students will be told how to proceed and evaluate. They can conduct learning preparations according to the daily schedule for tests and keep up with the progress. Topic discussions will be conducted in the second week, where the inventory of technical capabilities will be conducted and the current situation will be considered. The third week will focus on progress review tools and platform introduction and use, and explanation of the types of reports. The fourth week involves topic finalization, confirming the topic, and arranging the schedule for the project to progress smoothly. The fifth and sixth weeks involve progress review and evaluation. During the middle and the end of the semester, thematic sharing, observation, and feedback and questions from students will be conducted. At last, the chart is shown to allow all teachers to know the weekly progress or time allocation better. Third, preparations for students. First of all, the first part is the basic ability training. Before we proceed with the Applied Technology project, we cannot be certain that each student is equipped with the fundamental learning or basic understanding of the demo board. So, we can provide a few basic classes to allow the students to know what functions there are for the demo board chosen by the teachers, whether it be Arduino, microbit, or other boards. In this document, we have planned some items. The fundamental course mainly assists students in understanding the basic functions of the demo board. Teachers can select a few units for students to learn about the basic operations of the demo board. In this worksheet, we have listed a few items. The first learning theme is also the fundamental unit. We are going to learn about the control functions, or what sensor functions there are. The second part is the hardware requirement. For the hardware requirement, students can list the demo boards we have adopted and the relevant components, or even the corresponding model numbers. Other than allowing the students to learn about the model number differences and the functional differences of certain components. For instance, resistors, or to understand this component via other students, or even search online for the relevant model numbers and functional differences of the components. Thus, they can make arrangements with different models and functions when they proceed with the development in the future, or even make the purchase. The third part is that we hope the students can list the editing tools that they need for this basic functional unit, including the version and the control program code in this basic functional topic, and keep the original code. The fourth part is for the learning of the fundamental unit. Students can record the execution results in a video. This video can be presented with explanations for our project development in the end. Students also need to use such techniques to present their project for the performance presentation. For the fifth part, students are required to document in detail the problems they encountered in the learning process of the fundamental unit and how this problem was solved. For instance, consulting with other students, or conducting different tests, or asking the teachers, or even searching online and figuring out some methods to handle this problem. This is, in fact, also building the students' ability to learn on their own. However, teachers are asked to pay special attention to or remind the students, as electronic components are involved, what methods should be adopted to conquer the problems. And during the process of conquering these problems, will it be safer for the operating safety or under uncertain conditions? The last item we have on the list is asking the students to write down what they have learned from this unit, especially making some documentations in between theory and implementation. This will also benefit the students with the overall concept of the basic function. At last, a little reminder to the teachers. The purpose of writing the worksheet is to establish students' basic abilities. The students can understand the demo board via practices in this fundamental unit. Meanwhile, also cultivate the habit of writing documents through the record of the documentation. Secondly, the writing of document and writing skills can allow the students to rethink the learning points of the basic ability. Moreover, Documents can be accumulated where they can integrate the data when writing up the academic portfolio at the end of the semester. The aforementioned is the first part, the Introduction to the Fundamental Course Worksheet. Topic discussion. Requirements. Prerequisite knowledge. Technical capabilities. Part B. Next, we will introduce Part B to the teachers, the second stage activity. When the students have already learned the basic functions of the demo board in the previous stage, for the next step, we will take the students to conduct discussions on the project theme. Before deciding to proceed with a project, students should have certain concepts towards project development. Therefore, teachers can allow the students to search online for themes that have been researched or projects that have been previously conducted through everyone's research on the project. Cross-analysis and comparisons can be performed. At this stage, a special reminder to the students: the functions adopted for the selected project should be the abilities learned from the previous stage in Part A. If the students are capable of learning more functions independently on the demo board after the training in Part A, it is also encouraged. The second activity in the second stage is known as the inspiration of the project concept. The students must conduct some analysis on the project that they have selected, mainly to see whether or not this project conforms to the learning target of our applied technology project. This learning target mainly contains some requirement analyses and functional objectives. When we establish the project, or when we set the theme for the project, or when we are making sure what must be done for the project research, there must be clear demands or problems, and the project we make is to satisfy such demands or to solve such problems. The second point to the activity in the second part is checking the abilities. When students want to design a project, they must be able to clearly list out whether or not the functions to be used here can attain the capability index desired to be learned in our applied technology project or conforms to these learning contents. On the other hand, we must also review whether or not the content learned by the students from Part A, basic abilities, or some abilities that they have established on their own, can be fully applied to the project development. The aforementioned is Part B, the activity introduction to project theme discussion. How to find out the demands. Proceed with design thinking from observations in life, and exploring the demands is a necessary stage prior to the design. The quality of the demands will affect the quality of the design. It is even the key point in determining the success or failure of the end product. After all, demands matter the most from the user's point of view to see whether the products are good or not. If you did not try to understand users' real demands and expectations or explore the potential demands, you will be unable to hit the target regardless of how good or how efficient your design is. Everything will be futile. Moreover, you can also discover proposals via teachers, classmates, and the surroundings. Discover design points that can be developed from others' experience, and do in-depth surveys and research. Guide the students to actively collect data to extend the content from the existing learning for investigation. As a target-designated solution, requires the utilization of a target for in-depth data analysis in order to reach out to the right potential topic, through the right message at the right time. Through a target-designated solution, the key point can then be placed on the concept that is most beneficial to the topic development, thereby finding the demands and enhancing the performance benefit of the topic. Existing prerequisite knowledge and technical capabilities through the course practices can confirm the techniques that the students already know. Through the learning content of the extended course in the technological domain, choosing the hardware to be adopted, such as materials or equipment, understand that for the applications of different techniques, there are different compatible equipments or materials. Through the learning of programming language of the extended course in the technology domain, such as Python, C++, different computational thinking exists for different programming languages, but they are all capable of training the application ability for logical thinking, cultivating students' thinking transition. Establishing the schedule. First of all, back-thinking from the deadline to estimate the entire schedule for the project, starting from the topic collection to the final presentation. After planning the timeline, the second is to stipulate the completion date, which is also the presentation date. The third is testing the developers or the others. Experimenting is the most important part of conducting a project. Collect test data for evaluation and modification. Adjust the design pain points. The fourth is stipulating the project period 3, 2, 1, and arranging the progress check for each to prevent project delay. The fifth is system function analysis. System analysis puts the system functions into action to fulfill system goals. Apply scientific methods to the system for a detailed survey, analysis, comparison, and test, and stipulate a set of effective processing steps, and program based on this foundation, or propose a modification process for the original system to handle the problems comprehensively instead of in fragments. Consider the various main varying factors and their mutual influences to think and solve problems in all aspects. The purpose is to accurately propose the overall goal, to choose the proposal appropriately, and to confirm the strategy scientifically. The sixth is topic requirements. Find out the topic requirements, propose the solutions for the requirements. The seventh is stipulating the goals to be accomplished. At last, the eighth is completing the positioning, which is also the goal for the teachers and learners of this course. Fourth, academic portfolio. We will be introducing Part C, Project Progress Record. In Part C, the part we have provided is hoping that each student or each group of students has a fixed record. For instance, make a record once per week. This record is only recording what situations were encountered during the process of the project development, or what methods were used to handle, or what new approaches were learned in the technological aspect. Project Progress Management Tool. What needs to be managed in a project? The time course and the content development progress. Time course is a physical term to show the time course of an observer. The influence of speeding up matters a lot on the time course. The level of the project course can only be controlled by managing the planning of time and completing the required goals and the content development progress within the time limit. What obstacles will be encountered for the Project Progress Management tool? What obstacles will normally be encountered during the learning process? One can consult with the teachers and find resources for learning problems regarding technical bottlenecks. Or, if the function is too ideal, then modify the project goal. Situations that are in conflict with reality will be encountered during the design process. Accept the reality first and then slowly tangle with reality to understand the limits of reality and modify. Only then will we have the opportunity to break through. For other obstacles that may be encountered, such as lacking the originally planned resources, it could be components, etc., then we must have alternative plans. What else can be gained from a project other than the results? For instance, the accumulation of knowledge and techniques. In the course learning, each teaching can allow students to gain new knowledge while enhancing the technical aspect via the implementation process to accumulate practical experiences. For the result, it is also capable of enhancing the ability to conquer obstacles, to face different challenges, to use what has been learned and the surrounding resources to solve problems, and can work independently. Following the previous topic on conquering obstacles, since the problems can be treated seriously, therefore the parts requiring modification and adjustments can be seen, allowing the product to be more refined, thereby reducing the error rate. How to record this learning session. There are a few methods to the recording system for project progress that are hereby provided for everyone's reference. G Suite. G Suite is the short name for a complete set of cloud application programs. It can satisfy various needs, including contacts between enterprise users, file storage, management of project progress, and protection for data safety. It includes the commonly seen Gmail and Google Calendar, Hangouts Meet for convenient communication among colleagues, video conferences, sharing of itineraries, as well as various live online editing tools, including Google Docs, Slides, and Sheets. There is also the Google Drive and Workspace, etc., for storing and keeping, searching, and exporting the data for the various institutions in the specified application programs. Therefore, it features more user advantages for the sharing and collaborating part than having an individual Gmail account. Office 365. Microsoft 365 plans for home and personal use, as well as for small and mid-sized businesses, for enterprises, for schools and nonprofit organizations. The majority of Microsoft 365 plans for business use, schools, and nonprofits all include a conventional type of application program with full installation. However, Microsoft also provides an online version of Office, file storage space, and email function. You can determine the most suitable package for small-sized businesses, enterprises, schools, or nonprofit organizations. Blogger. There are many free blog platforms worldwide, and quite a few in Taiwan as well. If you want an easy and simple free blog, it is recommended to start with this Blogger platform. Through Blogger, it can help you set up a free blog. However, there are limitations too. For a beginner, this is a very simple and fast way for you to learn how to set up and operate a blog. Most importantly, to make you actually start to write something, when setting up a blog, this is the intention and key points for us. You can put your works on some websites, make them become your performance presentation websites. Site. Google Sites is a tool allowing anyone to make web pages and websites launched by Google many years ago. Especially suitable for the website used for internal teamwork in an enterprise, as it is capable of integrating data from services such as Google Drive. The most commonly seen example is that many teachers in Taiwan will use Google Workspace to set up a classroom web page, integrating class photo albums, homework, and course resources in Google Sites, allowing each student or parent in the class to review and use them. Moreover, to Google Sites, you don't need to know the one-line program code, as one only has to edit some data and layout, like editing a document before, to complete a team or classroom web page. Hence, it is ideal for internal website production for people in general. WordPress. WordPress is a set of content management system, meaning that you can perform functions such as managing a website and publishing articles easily through it. Most importantly is that you do not need to reinvent the wheel or how to write the program. You can still use WordPress to quickly set up a website with ease. If you are a program developer, then the level of freedom and flexibility of WordPress can also allow you to show your skills. Through the development of plugins, you can fulfill various desired particular functions on a WordPress website as long as you can write it out. You will definitely be able to apply and implement it on a WordPress website. Poster. Using the screen arrangement and instructions of the poster to put on the results, it is then a display capable of clearly presenting the production progress. Use both pictures and text to enhance the readability of the poster, allowing the readers to understand the execution process of the project. Academic Portfolio File. At last, produce the academic portfolio file. The teachers can customize the format, creating the file after completing the project for the convenience of storing the content. That way, the data can be clearly accessed from the activity record for future studies or interviews. Fifth, review and evaluation. Mid-semester progress review and evaluation. The objective of the review is to confirm the progress execution and part of the grade approval. The reviewed items can be discussed and determined at the beginning of the semester. The methods of the review include oral presentation, image record presentation, and functional tests, etc. The student's obstacle proposal or supplementary resources can also be used as one of the items for the evaluation. In-semester progress review and evaluation. The objective of the review is assessing the project and present the final results. The reviewed items include functional tests and completed documents or posters. The methods of review include oral presentation, functional tests, and peer reviews among classmates. Students can also present videos and the write-up of the academic portfolio file. Thank you for listening. I hope that this course is helpful to the teachers in planning and assisting the students to learn the knowledge and skills needed in the extended course of the Applied Technology Project. Thank you for watching.